Yesterday I introduced you to the chart on the wall, which looks like this, where you have an even and an odd degree and a positive and a negative leading coefficient. And that helps you figure out the end behavior. So if we have a polynomial function with an even degree and a positive leading coefficient, and you look in the box that jives with those two, you will see that the end behavior is arrows that go up. And you can see them on the wall there right under the exit sign. Okay. The other ones, two down arrows for even and negative, up and down with a positive slope for odd degree, positive leading coefficient, and then the other direction for odd degree negative. It's on the wall. Okay? You have to know those or be able to refer to that chart to do the problems. Okay? So, if I give you a polynomial with a degree of 4, how many solutions does it have? 4. They are not all guaranteed to be real solutions. We could have some imaginaries. So what I want you to do is, looking at this polynomial, draw a possible graph for this polynomial. Well, we're only looking at that term for this. We're going to get more specific in a minute where we're going to need the other terms. But for what we're doing right now, just drawing potential graphs, the rest of the polynomial is moot. Okay, we're only looking at the first term. The degree is 4, which means it's even. And the leading coefficient is 5, which is positive. So we need to draw a graph that fits our chart in terms of end behavior and has enough herky-jerk in the middle to where you have 4 potential solutions. Okay, so that would be a possible graph. If I draw on an x-axis there, you would see that that would hit the x-axis 4 times. It doesn't have to hit the x-axis 4 times, but it has to either hit the x-axis 4 times or hit it twice and then swing and miss for a couple imaginaries, or it could miss it altogether and have a couple imaginaries. So it could look like that, where it would swing and miss and then drop down and hit it once, or it could swing and miss twice. So it could be up here like that and have 2 imaginaries. But degree of 4 is usually some sort of W, even if it's warped and melting. Almost that brown one looks like it's melting. Some sort of W-looking thing is a 4th degree, or M if it's upside down. Let's try again. See if you can draw a graph for that polynomial function, a potential graph. Degree 3, which is odd. Leading coefficient 7, which is positive. Which means our end behavior is going to look something like that. But there has to be enough herky-jerk in your graph that it could potentially hit thrice an x-axis. So that would be something like that. It could swing and miss once. There's some other potential graphs. Has to be going up to the right and down to the left. If you have those switched, it's wrong. It cannot be rising to the left and falling to the right. When you have an odd degree, you cannot have all imaginaries, like I drew with that black W. You cannot have all imaginaries with an odd degree. You have to have at least one real solution. Let's try one more like this before we get to more specifics. Try that one. Okay, so we have odd degree of 7, leading coefficient that's positive. Our end behavior looks like that. Now we have to draw a graph that could potentially hit a x-axis 7 times. Three, 4, 5, 6, 7. Now you could have, you could add some imaginaries. You could add some double roots if you wanted to be creative. Here's another example of one that is a little more creative. In that case, we have an imaginary, 2 imaginaries, a double root, and a single root to get to our 7. Okay? Still has the same end behavior. You don't know, looking at the equation, what the answers are. You'd have to actually solve it to do that, which we're going to work on later. But the end behavior is really all we're talking about in this particular exercise right here. Okay?